clips of 4 rounds are placed in the loader. Automatic firing can be continued as long as ammunition is fed into the gun. Let us look inside the mechanism and see the cycle of operation when the gun is in automatic fire. First, a live round is fed into the mechanism. Second, the round is catapulted into the barrel chamber. Third, the breech is closed. Fourth, the round is fired. Fifth, the empty case is ejected. In automatic fire, each complete cycle occurs approximately every half second. When automatic fire is required, the firing selector lever located on the outboard side of the slide is set on auto fire. When the selector lever is at this setting, the gun will continue to fire as long as the firing pedal is depressed and ammunition is supplied. One setting is marked single fire. When the selector lever is at this setting, the gun fires a single round each time the firing pedal is depressed. One setting is marked safe on some mechanisms and stop fire on others. When the selector lever is at this setting, the trigger is locked in a non-firing position. Now let us study the construction and operating features of the gun. The barrel assembly contains a rifled barrel, which is surrounded by the water jacket in which cooling liquid circulates to keep the gun barrel from becoming excessively hot. At the end of the barrel is the flash hider, whose function is to reduce the brilliant flash near the muzzle. The barrel assembly contains the recoil spring, whose function is to restore the gun to firing position after recoil. That is, it supplies the force for counter recoil. The barrel is held in a housing by means of interrupted bayonet-type threads. The housing contains the breech block and associated parts. A slide assembly is provided in which the barrel and housing can move back and forth. It has a trunnion upon which the gun swings in elevation. Located on the outboard side of the slide is the hand operating lever, which is used for cocking the gun before firing can begin. Before cocking, the selector lever must be placed on safe. Then the hand operating lever is pulled all the way back to cock the gun. Then it is returned partway and latched in the rear catch bracket. The round may then be forced down into position. The hand operating lever is then moved forward all the way into the front catch bracket, and the gun is ready for firing. Now let us return to the condition before cocking and review the operation while studying the actions that take place within. As the hand operating lever is pulled back, the breech block is lowered. The hand operating lever is eased forward a little, causing the extractors to hook on and hold the block down. The rammer shoe was forced back as the hand operating lever was pulled and has compressed the rammer spring. The rammer shoe is caught and held back by the trigger catch lever. The loader contains star wheels, whose function is to assure that the round will be placed on the tray at the proper instant. When the hand operating lever is pulled back, the star wheel catches are rotated by linkages so that the star wheels are free to make a quarter turn, being prevented from turning further by spring-loaded pawls. The hand operating lever is moved forward into the rear catch bracket. The clip is pushed down, allowing the first round to take its position on the rammer tray. The hand operating lever is moved all the way forward, and the firing selector lever is set on auto fire. The round is now ready to go into the chamber. The rim of the round is located by slots in the rammer levers, which are mounted on the rammer shoe. Bear in mind that the round is not rammed into the chamber, but that it is catapulted into it after the rammer levers have released the round. After the rammer has reached this position, the rammer levers start to open, releasing their grip on the round. The round continues to move and travels forward until it arrives in the chamber. We shall repeat the actions. As it catapults into the firing chamber, the rim of the round engages the extractors and moves them forward into slots in the end of the barrel. As the extractors are moved, they release the breech block, permitting it to rise. In order to lower the breech block, the breech mechanism contains a crankshaft on which are mounted an outer crank and two inner cranks. The crankshaft is turned during recoil by a cam on the inside of the side door. During recoil, the roller on the outer crank contacts the cam in the door, turning the crank and thus lowering the breech block. On its way down, the block strikes the toes of the extractors, causing the extractors to eject the empty case. At one end of the crankshaft is located a spring assembly. It is called the closing spring because it acts to make the breech block rise. As the breech mechanism moves forward in counter recoil, the breech block is held down by the extractors until the round knocks them off as it enters the chamber, thus allowing the breech block to rise through the action of the closing spring. The breech block contains the firing pin which fires the round. Behind the pin is a strong spring. The firing pin has been held back by a cocking lever. This lever is called the inner cocking lever. The sear in this position prevents the inner cocking lever from releasing the firing pin. The sear is held in this position by a sear spring until the moment of firing. The sear has a slot. As the sear is pushed over by the right inner crank, the slot in the sear lines up with the inner cocking lever, allowing it to turn, thus releasing the firing pin. The firing pin is cocked by the left inner crank, which operates as the breech block lowers during recoil. The cycle of operation will be repeated. The rammer shoe is released. The rammer levers open. The round is catapulted into the chamber. The breech block rises, and the firing pin is released. As the gun recoils, the breech block goes down and the empty case is ejected. During recoil, the rammer shoe is carried back and held during counter recoil by the tray catch lever. During counter recoil, the next round is forced down to its position on the tray and the rammer spring is compressed. Near the end of counter recoil, the cam on the bottom of the tray actuates the rocker arm, causing the end of the tray catch lever to go down, releasing the rammer shoe. The loader contains feed pawls which move downward to force the round onto the tray. The feed pawls are moved upward during recoil and downward during counter recoil. The motion of the feed pawls is affected by feed rods whose movement is governed by a guide on each side of the tray. Rollers attached to the lower ends of the feed rods ride in the guides. The feed rods are raised during recoil, lifting the pawls above the next rounds. The feed rods are drawn down during counter recoil, forcing a live round onto the tray. In order to show more clearly the operation of the feed rods, let us view the actions from the rear of the loader. The feed pawls are spring-loaded. They retract in passing over the rounds during their upward travel. Spring-loaded stop pawls permit the rounds to be drawn down, but prevent them from being lifted upward when the feed pawls go up again. The bottom round rests on the star wheels until it is ready to pass to the tray. Then the star wheels rotate 1/4 turn, allowing the round to pass through. The next round is held by the star wheels during firing and recoil. At the proper instant during counter recoil, the star wheels release the round. Located at the rear end of the star wheels are journals, each containing 4 detents. For each star wheel, there is a spring-loaded plunger which positions the star wheel. The star wheel catches prevent the star wheels from turning before the proper moment. Then the star wheel catches rotate, allowing the star wheels to make a 1/4 turn. The catches are rotated by pawls on the top of the tray during the counter recoil travel of the tray. The last 2 rounds must be prevented from firing if the loader is not supplied with ammunition at a rate equal to the rate of fire of the gun. For if the last 2 rounds were fired, automatic operation would be interrupted and the mechanism would require recocking by hand. As we see, the gun will stop when ammunition in the loader has reduced to 1 round above the star wheels and a round on the rammer tray, because the loader catch lever will hold back the rammer shoe. The loader catch lever is operated by the feed control lever. As long as there is sufficient ammunition in the loader, the feed control lever will be held back and will keep the loader catch lever in the releasing position. But when there is only 1 round above the star wheels, the feed control lever will be released and the loader catch lever will assume the latching position, causing the gun to stop firing. When additional rounds are supplied to the loader, the feed control lever is forced back, the loader catch lever releases the rammer shoe, and firing will be resumed. The trigger mechanism is located on the inside of the outboard side of the slide assembly. The trigger mechanism comprises the trigger, the firing lever, and a pawl mounted on the lever. The trigger mechanism is operated by the firing rod connected to the firing crank, which is actuated when the firing plunger is moved in by depressing the firing pedal. The firing selector lever controls and limits the movement of the trigger. When the firing selector lever is moved, it rotates the firing selector cam. When the setting is on safe, the cam is turned so that the trigger cannot be moved, and hence cannot move the trigger arm which operates the trigger catch lever. Thus, the rammer shoe is prevented from moving. When the firing selector lever is moved to auto fire, the cam is rotated to a position that allows the trigger to be moved until it contacts this surface of the cam. The trigger maintains this position as long as the firing pedal is depressed. The trigger arm is moved by the trigger, and the trigger catch lever is maintained in the releasing position, allowing the rammer shoe to move, since the loader catch lever and the tray catch lever are both in the releasing position. When the firing selector lever is moved to single fire, the cam is rotated to this position. When the firing pedal is depressed, the action of the trigger is like this. The cam allows the firing lever to travel far enough so that the pawl releases the trigger, allowing it to be returned by the trigger spring. In single fire, recoil and counter recoil operate the mechanism as in automatic fire. Thus, in single fire, all operations except releasing the rammer shoe are automatic. These three catch levers are pivoted on a common shaft, and each serves to latch the rammer shoe in the cocked position at one time or another. The gun is set for automatic operation, and this is the condition before firing begins. The loader catch lever is held down in the releasing position when there is sufficient ammunition in the loader. The tray catch lever is also in the releasing position because the cam on the bottom of the tray contacts the rocker arm when the tray is in battery position. The trigger catch lever latches the rammer shoe in the cocked position until the firing mechanism is actuated. It will remain in the releasing position as long as the trigger is in the firing position. When the firing pedal is released, the trigger catch lever moves to the latching position. The loader catch lever is in the latching position only when the ammunition in the loader has reduced to 1 round on the star wheels and 1 on the rammer tray. The tray catch lever latches the rammer shoe during counter recoil, releasing it when the tray is about 1 inch from battery position. When the gun recoils, the recoil spring is compressed. The energy stored in the recoil spring is expended in counter-recoil, returning the gun to battery position. The action of recoil and counter-recoil would be extremely violent unless it were controlled by the recoil cylinder. The buffing action of the recoil cylinder results in smooth operation of the gun and controlled movement of the gun in recoil and counter-recoil. The recoil cylinder contains a recoil liquid, a mixture of glycerin and water. This fluid is caused to flow through ports and orifices during recoil and counter-recoil. The ports and orifices restrict the flow of the fluid, thus retarding the moving parts of the recoil cylinder. The parts within the recoil cylinder are the piston and piston rod. The piston rod is hollow and has ports connecting the inside and outside of the piston rod. The piston has a bushing. It also has tapered grooves on the inside. Here is the throttling rod, whose function is to control the flow of liquid through the bushing from one side of the piston to the other. It is tapered so that the opening between the rod and the bushing varies as the piston moves along. Within the throttling rod is located the needle valve. The needle valve can be adjusted to regulate the size of the opening through which fluid can pass, controlling the rate of flow from the hollow piston rod back into the recoil cylinder. Since in counter-recoil, the greater flow is through this valve, the speed of counter-recoil and consequently the rate of fire of the gun can be controlled by the setting of this valve. The tapered grooves provide passages for the fluid to flow to the rear during recoil and to the forward end during counter-recoil. Located at the rear end of the throttling rod assembly is the check valve. The check valve opens during recoil, permitting fluid to pass freely into the rear of the hollow piston rod. During counter-recoil, the check valve becomes seated, blocking the valve ports, and the fluid is forced around the valve seat through the grooves in the piston rod and through the valve seat past the needle valve. When the ends of the grooves are reached, the flow is restricted to the flow area at the needle valve. During the last part of counter-recoil, the flow area between the throttling rod and bushing decreases greatly, slowing down the counter-recoil movement of the gun mechanism as it approaches battery position. The length of recoil should be between 7.5 and 8 inches at 0 degrees elevation for the gun to operate properly. At the end of counter-recoil, the buffer pad provides a positive stop at battery position for the recoiling parts of the gun mechanism. The recoil cylinder limits the length of recoil and regulates the speed of counter-recoil. It enables the gun to operate at a controlled rate of fire and without jarring shock. All operations of feeding and firing the rounds and ejecting the empty cases are accomplished automatically through the action of recoil and counter-recoil.